In this video, I will give a quick introduction to Nansen, the neuroanalysis software ensemble package for MATLAB. Nansen is a collection of apps and modules for processing, analyzing, and visualizing data from two-photon imaging experiments. As you can see on my screen, Nansen consists of multiple apps. The InViewer displays two-photon recordings and other video data, and it also provides access to different plugins like ROI Manager and different methods for doing motion correction of images, among other things. The FOV Manager helps to register the location of imaging field of views and neurons on the brain in atlas coordinates. The Signal Viewer is useful for exploring extracted ROI fluorescence signals and other time series. And lastly, the Session Browser gives an overview of a list of sessions and the data and methods that are available for these sessions. The aims of Nansen are twofold. The first aim is for you to quickly organize and interact with your data without having to write a single line of code. Now, how do we achieve this? We start by building a data model using an interactive configuration dialog. Here it's possible to create one or multiple projects and then add different data locations to these projects. In this example, I have added 3 data locations, one for my raw data which is coming from the two-photon microscope, another one from raw data which is coming from my behavioral rig setup, and a third one which is consisting of my process data. After setting up the different data locations, I've configured the subfolder organization of these data locations. The different data locations have different number of subfolder levels, which I can configure and set up in this page. The last step is to create different data variables. The data variables are linked to files, and they can be connected to different file adapters which are used for opening the data. In this way, each session has access to a set of variables, and this is very useful later when we are working with session methods. The next step is to view and explore the data in modular apps. For example, here I have a corrected two-photon recording which I can browse in the InViewer. I can open a ROI Manager and then I can start adding ROIs to it. Now I show an average projection and then I have some ROI tools here. I'm gonna just mark a few circular ROIs like this. I can zoom in a little bit. And then I can open a Signal Viewer to start exploring also the ROI signals. So here you see the signal of this ROI for a few thousand frames. I can add another ROI to see the signals from it and compare the activity. Okay, and the last way to achieve this aim is to run the community toolboxes as plugins. And some toolboxes that are available are Normcore and Cayman and Su2P. The second aim is to show you how to build new tools by leveraging already existing apps and toolboxes. The easiest way to get started is to create new session methods. In the Nansen app, we can create new session methods using pre-configured templates. I'll show you a quick example. I can go to the session menu and create a session method. I give it a name. I select that it should take a single session as an input. It should be a function template. There's also a class template which is a bit more advanced. And I would put it on the menu location Analyze. I press enter and then in my MATLAB window there's now a new function which is open. It consists of a bit of code which is necessary to have it up and running, and then lastly there's this part of the function where you can add your own code. I'm going to add some code that I just wrote before here. It's going to print hello world, tell me which session it is and show what data is available for this session. I save my methods and then I go back to the Nansen window. And now under my Analyze menu, there's a method called test. I run the method on my session, which is my demo session. And we can see that it gives an output It shows which session this is, and it shows which data variables are available for this session. The data variables are unassigned. That just means that they are not loaded into the MATLAB memory yet. Another way to build tools is by adding plugins to apps. Let's look at an example for the InViewer app. In the InViewer, it's possible to visualize the images in different ways. For example, there are different projections that are available. I can look at the mean projection of the stack, or I can look at the maximum projection of the stack. Let's adjust the brightness here a little bit. But there are also other functions available, and it's easy to create new functions and add them to this menu by just placing them in a package in the InViewer folder. It's also possible to add functions for filtering images. I'm going to show an example of a Gaussian filter. I'm pressing Shift to get the options that are available. In this case, I can change the kernel size for the Gaussian filter. And this works the same way. You can add a function for doing the filtering and specify what parameters to use. And then this can be added to the InViewer folder, and it's available in the app. It's also possible to create more advanced apps. This can be done by combining multiple modular apps into data dashboards. I will show an example of a ROI manager that uses a combination of the InViewer, the signal viewer, and something called a struct editor. This is the ROI manager. I can scroll through the images and show different projections images as before. I also have access to different ROIs on the map. I can zoom in on some of these. And as you see, when I select the ROI, you can also see the signal of the ROI and a zoomed in version of an image of the ROI. There's a table here where we can sort the ROIs according to different variables. And the variables in this table is customizable, so you can add your own variables. Also, there are different controls in the ROI manager for changing how to visualize things in the image, and for running different methods like auto segmentation and signal extraction and signal processing. Ultimately, the goal of Nansen is to make it easier to dive right into the data analysis after doing a new experiments, and to accelerate the sharing of community toolboxes using a standardized interface. Nansen can be downloaded from our GitHub page at Vakelab, and after installation and configuration, it provides easy access to all your data and many calcium imaging toolboxes. With this, I really hope that you will find Nansen interesting and give it a try. The toolbox is still under development, and there are many features yet to include, but please try it out and don't hesitate to leave feedback and suggestions under our issues page. In the next video, I will talk more about the session browser. Stay tuned.